Picture this. You're looking up at the night sky, and suddenly there's something new hanging there, something massive, something that wasn't there yesterday. A rogue planet, wandering through the darkness for millions of years, has just crashed our cosmic neighborhood. And now Earth is being pulled into its orbit. This isn't science fiction. Rogue planets are real. Scientists estimate there could be billions of them drifting through our galaxy alone. Dark, frozen worlds ejected from their home systems, traveling through the void with no star to call their own. Most of the time, they just keep moving. Invisible ghosts in the cosmic night. But what if one didn't just pass by? What if it decided to stay? Today we're diving into one of the most terrifying yet fascinating scenarios in astrophysics. What happens when Earth gets caught in the gravitational grip of a rogue planet? Spoiler alert, it's not going to be a gentle ride. We're talking about massive tidal waves, volcanic eruptions, and weather patterns that would make hurricanes look like summer breezes. But here's the thing that'll blow your mind. Depending on the size and distance of this cosmic intruder, some of us might actually survive. I've spent weeks researching the physics behind this scenario, consulting with astrophysicists, and running through the calculations. What I found will change how you think about planetary stability forever, because it turns out our solar system isn't as secure as we'd like to believe. Let's start with the basics. Rogue planets come in all sizes. Some are smaller than Mars, others are massive gas giants that dwarf Jupiter. For our scenario, let's imagine something right in the middle. A planet roughly twice the size of Earth, dense, rocky, and carrying enough gravitational punch to seriously mess with our orbit. The moment this rogue world enters our solar system's outer reaches, things start getting interesting. At first, you wouldn't notice much. Maybe some slight changes in the tides, a few unusual aurora displays as our magnetosphere gets disturbed. But as this planetary invader gets closer, Earth begins responding to its gravitational call. Here's where the physics gets wild. Earth isn't just going to smoothly slide into a new orbit around this rogue planet. Oh no, it's going to be dragged kicking and screaming. Our planet's crust would start flexing like a stress ball in the hands of a cosmic giant. The first thing you'd notice is the earthquakes. Not your average tremors, but massive, continent-shaking quakes as tectonic plates shift under the new gravitational stress. But earthquakes are just the opening act. As Earth gets pulled closer to the rogue planet, tidal forces begin tearing at our world. The side facing the intruder experiences stronger gravity than the far side, creating a stretching effect that would make our planet bulge like a football. This tidal stretching doesn't just affect the oceans, it affects the entire planet, including the molten rock beneath our feet. Imagine standing on the coast and watching the oceans suddenly surge hundreds of feet higher than normal, then recede just as dramatically. These aren't tsunamis caused by earthquakes. These are the oceans themselves being pulled back and forth by competing gravitational forces. Coastal cities would be wiped clean. Entire continental shelves would be exposed and then flooded again in cycles that could last hours or days. And then there's the volcanic nightmare. All that tidal flexing of Earth's crust creates friction deep underground. Friction generates heat. Heat melts rock. Suddenly, dormant volcanoes around the globe start waking up. The ring of fire becomes a literal ring of fire as magma finds new paths to the surface through cracks created by the gravitational stress. But here's where it gets really interesting. The atmosphere itself starts behaving strangely. As Earth gets stretched and compressed, air pressure fluctuates wildly. Weather systems that took days to develop now form in hours. Hurricanes spawn in the middle of continents. Temperature gradients become so extreme that you could have a blizzard on one side of a mountain range, while the other side bakes in desert heat. Now, let's talk about the orbital mechanics, because this is where things get truly mind-bending. Earth doesn't just fall straight into the rogue planet's orbit. Instead, our world begins tracing complex, chaotic paths through space as it tries to balance the gravitational pull of the Sun, the rogue planet, and its own momentum. Some computer models suggest Earth might end up in a figure-8 pattern, swinging between the Sun and the rogue planet like a cosmic pendulum. Other scenarios show our planet spiraling inward toward one or the other in a death dance that could take years to complete. The worst-case models have Earth getting ejected from the solar system entirely, becoming a rogue planet itself, frozen and lifeless as it wanders through interstellar space. But not all outcomes are apocalyptic. If the rogue planet is just the right size and captures Earth at just the right distance, we might end up in a stable orbit around our new planetary companion. Think of it as becoming a moon to a larger world. The surface changes would still be catastrophic, but life might find a way to adapt. Human civilization as we know it would collapse, but pockets of survivors could potentially rebuild in underground shelters or in regions that remain tectonically stable. The real question becomes, how do we survive the transition period? Because even in the best-case scenario where Earth eventually settles into a stable orbit, the journey there would be absolute chaos. We're talking about years, maybe decades, of geological and climatic upheaval that would test every survival instinct humanity has ever developed. Picture the first few months after capture. Global communication networks collapse as satellites get thrown off course by the shifting gravitational fields. GPS becomes useless when your reference points are constantly moving. The International Space Station and every other orbital facility either crashes back to Earth or gets flung into deep space. We'd be cut off from our technological lifelines, forced to rely on ground-based systems that are themselves under constant assault from seismic activity. Food production becomes a nightmare scenario. Traditional agriculture fails when seasons become unpredictable, when day and night cycles stretch or compress beyond recognition. Solar panels become worthless when the sun's path across the sky changes daily. Wind patterns shift so dramatically that weather prediction becomes impossible. Farmers who've worked the same land for generations suddenly find themselves dealing with soil that's been churned up from deep underground, contaminated with minerals that were never meant to see daylight. But here's something fascinating that most people don't consider. The rogue planet itself might not be completely lifeless. If it's been wandering through space for millions of years, it's definitely frozen solid on the surface. But deep underground, radioactive decay and leftover heat from its formation might still be keeping pockets of liquid water warm. Some scientists theorize that these subsurface oceans could harbor microbial life, organisms that have evolved to survive in complete darkness, feeding off chemical energy instead of sunlight. Now imagine what happens when Earth's intense magnetic field and atmosphere start interacting with whatever's left of the rogue planet's environment. We could see the most spectacular aurora displays in human history as charged particles from both worlds dance together in space. The night sky would become a constantly shifting canvas of greens, blues, and reds as our magnetospheres merge and clash. The psychological impact on survivors would be unlike anything we've ever experienced. Imagine looking up and seeing not just the moon, but an entire world hanging overhead. Sometimes it would appear larger than the sun, close enough that you could make out surface features with the naked eye. Mountain ranges, impact craters, maybe even frozen oceans that once flowed billions of years ago. The human mind isn't wired to process having another planet as a permanent fixture in the sky. Some regions of Earth might actually become more habitable, at least temporarily. The gravitational interaction could trigger massive shifts in ocean currents, potentially warming areas that were previously too cold for human settlement. The Arctic might become temperate while tropical regions freeze over. Entire ecosystems would be forced to migrate or adapt at speeds that evolution never intended. Underground becomes the new frontier. Mining operations that were once economically unfeasible suddenly become essential for survival. Natural cave systems transform into refugee centers. Subway tunnels in major cities become highways connecting isolated communities. The deeper you go, the more stable things become, shielded from the worst of the surface chaos by miles of rock. Technology would have to evolve rapidly or we'd lose it entirely. Solar power fails when the sun's position becomes unpredictable, but geothermal energy becomes incredibly abundant with all the volcanic activity. Hydroelectric power might work in some regions, but good luck predicting where the rivers will be flowing next month. Wind power becomes a joke when atmospheric pressure can drop to near vacuum levels one day and spike to crushing heights the next. The most successful survivors would be those who can adapt fastest to a world where the only constant is change. Nomadic tribes might have advantages over settled civilizations. People accustomed to living off the grid could outlast those dependent on infrastructure. Ironically, the same technological dependence that makes modern life comfortable could become our greatest weakness when the rules of physics start getting rewritten around us. But here's the wildest part about this whole scenario. If humanity somehow manages to survive the initial chaos and establish stable communities on this new Earth-rogue planet system, we'd essentially become an interplanetary species overnight. Not by building rockets and launching into space, but by having space come to us. We'd have two worlds to explore, two sets of resources to exploit, and potentially two different evolutionary paths for human development. The descendants of the survivors might develop into something unrecognizable to us, adapted to higher gravity, extreme weather variations, and radiation levels that would kill us instantly. So what's the verdict on Earth's cosmic kidnapping? From continent-crushing earthquakes to skies painted with alien auroras, from underground civilizations to the complete rewriting of human evolution, a rogue planet encounter would be the ultimate test of our species' adaptability. Most scenarios end badly, really badly, but that tiny sliver of possibility where we somehow pull through, that's where things get absolutely fascinating. The truth is, our solar system has been playing a delicate balancing act for 4.5 billion years. Every planet, every moon, every asteroid perfectly positioned in this cosmic dance we call home. One rogue world could shatter that balance in an instant, turning Earth into either a frozen wasteland drifting through space or a volcanic hellscape orbiting an alien world. But maybe that's exactly what makes this scenario so compelling. It forces us to confront just how fragile our existence really is, and how incredibly precious this little blue marble we call home truly is. Because when you strip away all our technology, all our cities, all our comfortable assumptions about tomorrow, what's left is the most remarkable survival story in the known universe. Next time you look up at the night sky, remember that somewhere out there, invisible and silent, billions of rogue planets are wandering through the darkness. Most will never bother us, but all it takes is one. Would you be ready? Let me know what you think in the comments below.